Chapter 12. The Birth and Growth of Darwin's Theory. Huzzah! As everyone knows, a part of the story of the creation of the earth is given in the book of Genesis as follows. And God said, "Let the earth bring forth grass and the herb, yielding seeds, and the fruit tree yielding fruit after his kind, whose seeds is in itself upon the earth. And God created great whales, and every living creature that moveth, which the waters brought forth abundantly after their kind, and every winged fowl after his kind. And God said, Let the earth bring forth the creature after his kind, cattle and creeping thing, and beast of the earth after his kind." Until about the 1860s, people took the words of the book of Genesis as literally true. They believed that these words were an account of what they called, quote, special creation, unquote. That every kind of plant and animal had been created in those first days of the world, and that all living things after their kind had come down exactly as they were made, generation after generation. It is true that the Greeks in the 4th century BC had talked of organisms that changed from one generation to the other, but their ideas had been forgotten. Later, Baron Cuvier, looking at fossils embedded in strata of rock, had talked of catastrophes that destroy the life of a whole generation and made a new creation necessary. Lamarck had thought that all living things were related and that one species developed from another, but no one in his time thought much of Lamarck and his theories. There had been only a few others who regarded the book of Genesis as poetry and not as a factual account of creation. Even most scientists up to the end of the 19th century accepted the fact of special creation without question. Then Charles Darwin brought the idea of organic evolution sharply to people's attention. It was he who proposed a theory of how and why one species developed from another. In 1859, his great book, The Origin of Species, was published, and after that, people's whole outlook on nature seemed to change. It was rather strange that Darwin should have worked out the theory of organic evolution, for at first he believed in special creation as firmly as anyone could. In the beginning, he had no thought of being a naturalist. His father, in fact, was quite discouraged with him, for in his early years he seemed to care for nothing but horseback riding and pheasant shooting. His father feared that he would become, quote, nothing but an idle sportsman, unquote. Finally, however, Darwin agreed to study at the medical school at the University of Edinburgh, for both his father and his grandfather were doctors. But the lectures at the medical school appeared to him dull, and he could not bear the sight of operations. They were administered in those days without anesthetics, so he left the medical school. After that, and there was a good deal of argument first, he agreed to study for the ministry. He thought he might become a country minister. He loved country life, and had begun some collections of beetles and butterflies. Reluctantly, then, he enrolled as a theological student at Cambridge, and there he met Professor John Stevens Henslow, the geologist and botanist. Almost immediately, Henslow and Charles Darwin became fast friends. They were seen walking together so often that the students of Cambridge called Darwin, quote, the man who walks with Henslow, unquote. It was during those years and under Henslow's influence that Darwin began to read the works of the great naturalists. He read of Alexander von Humboldt's personal narrative of travels to the equatorial regions of America, and longed to set foot in the New World. He read Sir John Herschel's Introduction to the Study of Natural Philosophy, and dreamed of adding something humble but substantial, perhaps to what he called a little pompously, quote, the noble structure of natural science, unquote. His opportunity to add that structure came much more quickly than he anticipated. In the late summer of 1831, the HMS Beagle was to make a cruise around the world for the purposes of mapping and scientific observation. The captain, Robert Fitzroy, wanted a scientist to go on the expedition, quote, a scientific person to examine the land, unquote. Professor Henslow recommended Charles Darwin for the post, and Darwin was filled with excitement. To go to the equatorial regions of America as von Humboldt had done, to have a chance to examine minerals and wildlife in the regions where he had never been before, seemed to him the opportunity of his life. But his father objected. The boy ought to finish his theological course, he said. He had wasted enough time. Charles Darwin's uncle, Josiah Wedgwood, who was the owner of the famous Wedgwood potteries, saw the youth's point of view. He had his horses harnessed to his carriage and drove more than 30 miles to see the elder Darwin. In the end, the permission was given, and Charles Darwin set off for the Beagle. But now he encountered another difficulty. The captain of the vessel hesitated to accept him. He doubted, he said, quote, whether a man with such a shaped nose could possess sufficient energy and determination for the voyage, unquote. How strange, Charles Darwin said years later, quote, I became a naturalist only because my uncle was willing to drive 30 miles to see my father, and because the captain finally decided he did not object to the shape of my nose, unquote. His Majesty's ship Beagle, a 10-ton brig, sailed out of Davenport on the 27th of December, 1831. She was bound for Patagonia, and thence through the Straits of Tierra del Fuego, and so on around the world. Quote, it was the most important event in my life, Charles Darwin later wrote. The little brig pushed out across the Atlantic, and soon she encountered rough seas, so the young naturalist lying in his bunk was miserable with seasickness. This sickness was to plague him off and on whenever the vessel rocked throughout the 5 years of the voyage. They landed on the South American coast, and Darwin began his collections immediately. Soon he had minerals, shells, and plants arranged systematically in the small room behind the mast, where he also kept his books and instruments. Since the space allotted to him was so small, he decided not to collect many specimens, but to choose each one as carefully as he could, and classify it in as orderly a way as possible. Day after day, the vessel sailed along the South American coast, and the young naturalist, who had never been out of England before, watched the unfolding panorama of the South American shore, the dark Brazilian forests with their rich life of birds, reptiles, and animals, the high grass of the pampas in Argentina, the bleak, rocky heights of Patagonia, where the wind never stopped blowing. For though the Beagle was to push on across the Pacific into the South Seas, the greater part of her voyage was spent along the coast of South America. As they sailed down the coast, Darwin went ashore at frequent intervals to study the land, the mud, the rocks, the fossil bones, the fungi in the dark forests, the ostrich on the high plains, the flamingo that fed on the worms of the salt lakes of Argentina. When the Beagle laid over for a month at one of the Galapagos Islands, 500 miles from the South American coast, strange and disturbing thoughts began to enter Charles Darwin's mind. On this island, which was composed of volcanic lava recently cast up from the sea, he said he felt himself, quote, placed in proximity to the very act of creation itself, unquote. Here he found animals that were certainly of the same genera as those on the mainland of South America, yet they were not the same. They seemed to be of different species. And as the Beagle moved on, visiting one island after another, he found that each island had its separate species of plants and animals. Now, he thought, watching the rim of the ocean as the little vessel pushed across the sea, why had a separate species been created for each small island? The making of such multiplicity of species seemed at least irrational. Why were there thousands of different species on those islands? Why did they belong to the genera of South America, which was miles away? Seeds might have blown across from the mainland to the islands by the winds. Animals might perhaps have swum across. But if this was true, why was each of the species on the island a little different from those on the mainland? The problem troubled him. Characteristically, he said nothing about it, however. In the small yellow notebook, he started to make notes on his observations. After he reached England again, he wrote to Joseph Dalton Hooker, the botanist, quote, At last gleams of light have come, and I am almost convinced, quite contrary to the opinion I started with, that species are not, it is like confessing a martyr, immutable, unquote. But the confession of the murder was later. For the present, he was simply examining the facts. Finally, the Beagle docked at Falmouth October 2nd, 1836, and Darwin, who had suffered from seasickness almost every day of the 5-year voyage, found himself on firm land again. The voyage was over. Darwin's letters and part of his specimens had arrived in England before him, and his reputation as a naturalist was now well established. Scientists greeted him enthusiastically. Charles Lyell, the Scottish geologist, whose book Darwin had carried all the way around the world, now became his friend. Joseph Dalton Hooker was eager to know him. Robert Brown, the Australian microscopist, showed him discoveries he had made with his lens. The great German naturalist von Humboldt, then visiting England, asked to meet him. Thomas Carlyle and Thomas Babington Macaulay made much of him. But Charles Darwin wanted to get away from all of them. After 3 years in London, he married his first cousin, Hannah Wedgwood, and they bought a roomy, comfortable house with a garden at Down, a small town in Kent. There he was to live and work for the rest of his life. The problem that Charles Darwin wanted to study was the one that had perplexed him first on board the Beagle. Had the God whose special creation he had taken so much for granted really created so many thousands of species, all of them so nearly alike yet different? Or was it possible that the idea of special creation might be wrong? Was there some sort of relationship between species? He had heard of the work of Lamarck, but he thought nothing of it. Rubbish, he called it. Cuvier's idea of catastrophes seemed to him foolish too. He decided that he might get some help by studying domestic animals, since these were near at hand and easy to observe. He began a correspondence with a large number of breeders and started to breed different races of pigeons himself. He found that man could certainly modify the breeds of dogs, of cows, of pigeons. There must be some force in nature that works the same way, he thought. But what was it? Then one day in his study at Down, he happened to pick up and read, for diversion, a book by the English minister Thomas Malthus. The book was called An Essay on the Principle of Population. Reading that book made Darwin see the solution of his own problem. For Malthus pointed out that the population of the earth was continually growing by geometric progression. If war, hunger, and disease did not kill a part of the people in each generation, there would hardly be room for them to stand on the earth. There would certainly not be food enough to feed them. Something like that must happen in all nature, Darwin thought. All organisms must increase at an enormous rate. Linnaeus had said somewhere that if a plant produced 2 seeds each year, and if each of these produced only 2 seeds in the same way, 1,000,000 plants would be descended from the first one in only 20 years. Darwin kept thinking of that. And take animals, he argued. An elephant is a very slow breeder. But if a pair of elephants produce 6 young in the course of their lives, and each of these does likewise, in 750 years there would be 19 million elephants on Earth. They would have a struggle to keep alive, he said. This, then, might be the answer, he thought, a continual struggle to exist. But granted, as he could easily observe, that every member of a species is not exactly like every other, granted that there are some variations among them, what determines which ones will survive? What determines which plants or birds or animals will live and which will die off? How is the balance so beautifully kept that the world is never overrun with elephants or stifled with oak trees? The answer he found to his problem came to him slowly, as he sat in his comfortable library with its book-lined walls, as he walked through his garden at dawn, as he watched his cattle cropping the grass in his pastures. He could not tell exactly why there was a slight variation in the offspring of each plant or animal. That slight variation will quote, provide a grand and hitherto untrodden field of investigation, unquote, he said. But it is certain that some green beetles are a little greener than others, that some swallows have stronger wings than others, that some deer are quicker to hear the sound of danger. And among these, those that are best fitted to adapt themselves to their environment survive and reproduce their kind, while the others die off. By piling up variations in one direction over long ages of time, new species are formed. The idea of special creation now seemed like an idle dream to him. As he walked through his fields, often accompanied by his terrier Polly, he examined plant and animal, bird and insect, considering his theory as he went along. The years went by. He was still testing, examining. He wanted to be sure of his facts. He wanted to accumulate scores of facts. Sometimes he wrote to his friends about what he was trying to do. In 1842, he wrote his friend Sir Joseph Dalton Hooker, quote, I've been ever since my return engaged in a very presumptuous work, and I know no one individual who would not say a very foolish one, unquote. In 1844, he wrote out in pencil a brief statement of his new theory and showed it to a few friends. They urged him to hasten to publish it, but he said there were more data to be collected. He wanted to be so sure that he was right. Then, in June 1858, a letter arrived from Alfred Russel Wallace, a naturalist working in Malaya. Wallace had worked out exactly the same theory. Darwin was a generous man and not ambitious. He thought that Wallace should publish his findings and receive the credit for them. Quote, I would far rather burn my whole book than that he, Wallace, or any other man should think I had behaved in a paltry spirit, unquote. But Darwin's friends Lyell and Hooker knew that he had been working on his theory for years, though he had never officially published it. They proposed, therefore, that both Darwin and Wallace should be given credit for the theory, and this was done. At the Linnean Society in London on July 1st, 1858, papers written by both Darwin and Wallace announcing the theory of evolution and the survival of the fittest were read. In 1859, Darwin published his famous book, The Origin of Species, and it was followed in 1871 by another book called The Descent of Man. In the latter book, he applied the doctrine of the survival of the fittest to human beings and drew the conclusion that, quote, man is descended from some less highly organized form, unquote. The uproar that followed the publication of Darwin's theories must have been heard even in the quiet garden of the house set down. For most people are conservative and do not like to see their well-established ideas upset. Some of the churchmen objected to his rashness in questioning the doctrine of special creation. Some of them thought he implied that men were descended from apes, though actually he had never said any such thing. What he had said was that all human beings were descended from a common ancestor. Still in England, on the continent of Europe, in the Americas, the controversy he had stirred up raged on. He grew to be an old man who walked about his garden in a long black cloak, his beard snowy white, but his gray eyes still keen beneath their overhanging brows. He died in 1882, and his countrymen took his body to Westminster Abbey, where they buried him beside Sir Isaac Newton. And still the controversy about his theory raged. But gradually, one after another, the voices of his enemies were quieted. Gradually his ideas were accepted. Although his theory was amplified and changed as the years passed, organic evolution is still the idea on which modern science is built. Theodosius Dobzhansky, a present-day biologist, has written, quote, "We now think the things we see around us is not always as they were now, but evolved gradually from very different looking ancestors. That these ancestors were in general less complex, less perfect, and less diversified than the organisms now living, that the evolutionary process is still underway, and that the causes can therefore be studied by observation and experiment in the fields and in the laboratory." Unquote. That is exactly what Darwin thought nearly 100 years ago. The work of the biologist since his time has been very largely an attempt to elaborate on his theory.